Hey everybody, this is Larry. This is Leetcode Weekly Contest 185. I'm super excited. Let's go. Let's do this for about 40 seconds. Hit the like button, hit the subscribe button. Yeah, stay tuned for the explanation near the end. We'll try to explain each problem. And yeah, the links below to kind of jump ahead if you want to skip to the explanations. About 20 seconds. Wish me good luck. Hit the like button, hit the subscribe button, leave a comment. How did you do? What do you think of the prompt and contests and stuff like that, right? Let me know. Would love to hear from you. And we have 14 seconds. So, yeah. Ooh, calm down. Good, and then here we go. And here we go. And this time I actually remember to register, so it's a little bit faster. Watch my previous video if you don't get the reference. But we format the string. So this one, yeah, double checked a little bit on how to on the reading, but overall not a tricky problem. You just have to follow the instructions. There are only 3 different cases that you can do in different ways, which is if they're more if they're more alphabet than numbers, if they're more numbers than alphabet, or if they're equal. So I kind of, first of all, I started by separating them out because it doesn't really matter the input order. And also it doesn't really matter which one you put in A and which one B as my code. But actually, I probably could have done this a little bit better. But yeah. And oh yeah, the impossible case is the case where if you have way too many letters or way too many numbers, you could, I mean, you could show why you can show why that's true very quickly. I'll leave it up to the watcher to prove that. But yeah, so now we know that it's going to be only 0, 1, and -1 in terms of the delta. Um, yeah, so then there are only 3 cases. I actually flip and flopped a little bit on how to write this. I was like, oh, wait, we could actually merge them into one for loop and then just do some crazy statements. But then I was like, oh, eh. I mean, I actually could have still done it that way, but I think I was just a little bit worried about handling all the edge cases of the permutation of them and the interaction of how they handle together. So instead, I was just like, okay, let's just play it safe. Let's just write their own cases so that it's true. And then that's pretty much it for this problem. I mean, I did a lot more typing, to be honest, but please. Yeah, and then I test that. Yeah, and then I was like, okay, I wanted to double check just to on the reading. I wanted to be a little bit careful with this contest. The submit was great. Yeah, problem 2. This one was a little bit of a reading, so I just kind of started reading. I was like, huh. I was like, there's a lot of reading. Okay, slow down and actually read it. But yeah, after reading, I was like, oh, this is just aggregating stuff and then printing them out, like almost like an Excel or something like that. So I was like, okay, let's do this. And I was also I think at this point I was like, what does the name do? Like the orderer's name, like Laura and James and whatever. And I was like, and I think that's the part I was a little confused about. But now I'm just setting things up in orders. Yeah, now I'm just setting up the columns. I probably could have named that a little bit better, to be honest. But now I wanted a column, or keeping track of all the food that people have ordered, and also keeping track of the mapping between table and food item. That's kind of what I did. But yeah, double checked. I was like, okay, that's actually table number, because for some reason I thought it was count, obviously. And I was like, no, that's not the count. Or I was like, if that's the count, where's the table? Where do you get the table number? So I was like, okay, reread it, and that's pretty much it. I wanted to keep track of the tables. Could probably have done it with the count keys, but I was like, okay, let's just make it explicit so that I don't have to worry about things, which actually made it a little bit easier to debug things later on, as you will see, because it wouldn't have been that much harder, but it would have been more, this is more direct as a result. But yeah, so I first created the header, then the header is just the word table, plus all the list of the items, of the food items. Yeah, and then after that, I mean, it's pretty straightforward. I was trying to think about a clever way of doing it. I was just thinking about it a little bit. It was like, okay, yeah, and we just look up the count of the food of the lookup tables of the columns. And this is actually straightforward. However, there's a lot of things wrong here. So I probably could have done, but looking back, a lot of people also did it much longer. So I actually, I thought that, like, as a competitive programmer, I just have a mental clock, and I was like, okay, I'm probably a little behind, but that's okay. Let's just get it right. Let's focus. This is a tricky problem. There are a lot of edge cases. I know myself. I'm very prone to making silly mistakes, and I was like, okay, this is really hard to compare to the top results. But I was like, okay. First of all, I noticed that was in string. Uh, So what I did is I actually copy and paste the results to a text. You can't see on screen, but a notepad of sorts, so that I could kind of compare them, like by alt tapping instead of going up and down, which is what I usually do, because there was a lot of nuance. And I was like, oh. And then I just noticed that, and this is why we test, that I was actually sorting by the string value of the table number instead of the int value of the table number. So that's what I'm doing here. And I kind of refactored that out a little bit so that I could, I'm thinking of how to write that in a cleaner way. And you kind of see me like sort by the int. And actually I could have written this a little bit differently, to be honest, but I just did it this way, converting it back. And then there's still another issue, because this problem is annoying as hell, but in a fun way. Like, I mean, and I copy and paste the input instead of I was like, wait, this doesn't look like the output. And then I was like, okay. Now I looked again. I was like, huh. So this time you can't really see it, so I was off screen a little bit. But my array was all zeros. So I was like, where did the numbers go? I don't know if it was right before, but I was like, oh, yeah, because the lookup is now a string. So I ran it again. So very thankful that, as you can see, the Leetcode server is really fast, because if I had to wait 20 seconds for every one of these tests, it would have been added a lot of minutes to my time. So after double checking, that looks okay. I accepted, and or I submitted, and it was accepted. Minimum number of frogs quirking. So this one I probably could have done a little bit faster, but I think I was just trying to really understand it. I was going through a little bit. I was just trying to go through algorithms in my head, and reading this, I wasn't sure that I could convince myself that I was greedy, to be honest. Um, but there is if you watch the end of my video, I will explain actually the some of the proofs and how to explain it. But what I'm going through here is I was like, okay, I'm not quite sure, but I think let me try to do a greedy algorithm. And what would that look like? So that would just be counting the number of frogs in each state, each equivalent state, uh, equivalence class rather, and then kind of go forward from there. Also terrible variable names, but yeah. And I just look up the thing and I go for each one. And actually, at this point, it seems like I actually mostly had the algorithm ready, but I wasn't. I think at this point, I had some doubts again on the proof, so that's why I was like a little bit weird. Uh, Everything is just a little weird in general, but if k is greater than 0, which it always is, but and I do clean up on this code a little bit. Yeah, and right now I think I was having doubts about my greedy algorithm, and that's where the time lag is. And I was thinking about binary search and stuff like this. Uh, and I was trying to, I was like, I guess I was thinking about like, okay, if I did a binary search, 10 to the fifth is 100,000. 100,000 n log n of that is not so bad. But I do worry a little bit about obviously just getting binary search right is kind of hard to, is a little bit tricky. A little bit tricky to kind of get it right. But it's doable. And I was like, and then after writing that out, I was like, everything I do here would have been essentially the same as greedy if I keep track of it in another, in like a initial variable or something like that. So that's what I end up doing. My explanation is a little bit terrible right now because it's not meant to be an explanation. It's just in the sense that it's this is I'm just trying to articulate what I'm going through mentally as I'm solving this. So what I'm solving this is, and if what I'm saying sounds confusing, is because my mind was confused when I was solving this. If you want the explanation, check out the link in the description, and if you click on it, I will explain the problem there about how I kind of prove this to myself later on. But ongoing contest. Why is this so long? But here I'm just trying to be like, okay, can I actually do it this way? And like, I'm just trying to think about counter cases as I'm writing it out. But yeah, I was still trying to convince myself. I was like, wait, k is always going to be greater than 1. But uh, um, but yeah, and I was trying to think about like the last state you don't need it. Can I just remove it from the first item and like and that is that good enough? I just wanted to make sure. That's all. Oh, like this not like I think I definitely was also being more careful than I would normally, just to kind of think right now. Um, yeah, and obviously I got the wrong answer, so I was well, not the wrong answer, like I didn't submit, but I was like, this answer isn't right, so what am I missing? Oh, the case where some of the flaws don't make it to the end. So that's kind of what I'm thinking for in right now and testing. Uh, um, Yeah, this one is okay. I probably, if I was more YOLO, I probably would have submitted. But I was like, huh, so this is a silly like 40 seconds or whatever it is, where I was like, huh, why am I not printing the D? Because I was expecting an array where, or an output where, for the last case, I was like, why is that not printing? And the short reason is because I put the print statement after the if statement. So actually, it was correct. It's just that so I wasted a minute debugging something as a result. But maybe I was just need to be a little bit more pay attention and stuff like this. Um, um, but yeah, after seeing that, I was like, okay, well, I just wasted a minute, but it is what it is. And yeah, so Q4. So let's see, but, that minute would have been. It's okay. Build a way where you find the maximum exactly k comparison, given n, m, and k's. I think to be honest, for this one, while when I was reading, I was very tempted to keep on skipping ahead. But yeah, so I kind of did a little bit. I was like, this is a very easy problem, and I did a refresh just to see, and like 5 people already solved this problem while when I was starting, which is very impressive, of course. But you know, people don't always solve in the right order anyway, so that's okay. Um, but yeah, so here I'm still just reading, just trying to see if I could figure out a pattern. And I was like, okay, well, I think also, I mean, it actually happened to be one of the cases in the examples, but I was as soon as I saw the mod, I was like, okay, drop everything, take care of the mod. I have gotten way too many wrong answers not handling it, because you can't always assume that the examples will contain that, even though it should. But yeah, so immediately I knew how to solve it, kind of, because I think I was solving the wrong problem. Um, I think look, so okay, so I think what ended up happening is that I forgot about the problem. I looked at the first example case and I was like, okay, it's just the number of arrays that are decreasing from like strictly or not strictly, but monotonically decreasing, and that's what I end up solving or trying to solve. So you could actually see, so in a way, I actually solve multiple problems with this dynamic program problem, and you'll kind of see me do this here. Um, and I was blind to the point where I didn't even use cost or k at all. So yeah, so here, if in that case, my recurrence was like, okay, start the index, start at the highest value, which is m, and then you could kind of do a for loop from well, I would from 1 to m, but yeah, 1 to m, but you could do it from m to 1. But essentially, you're going like, okay, for every number, try it, and what's my base case? Well, if we reach the end of the index, that means we filled out a full array, so the answer is 1, and then otherwise, it's straightforward. Straightforward if this was the problem. And if this was the problem, I would gotten it in about 2 minutes, uh, apparently. So I hope that's a future problem, maybe. That'll probably be a future medium, if anything, especially after today. Um, I did think about the constraints a little bit, but to be honest, I was a little bit wrong because at this point, I thought it was n times m times m. Um, but you see that I actually added a dimension later and just didn't think about it. So that was kind of a little bit YOLO on my part. And on more difficult competitive programming contests, maybe that would be an issue. But for this one, um, I didn't have to. And I was roughly done, except for that the answer, and if the answer were all correct, which luckily there were enough, because if there was only one example, then I would have gotten it wrong and gotten a wrong answer. I would have been like, okay, submit. And I would have gotten it in about 20 minutes. So that would have been 3 minute solution. But I was like, why is this wrong? And I was like, wait, there's a cost thing. What is this cost thing? Yeah, exactly. I didn't even notice the cost thing until now. I don't know how this happened. I think I saw a easy problem that was clearly dynamic programming, and I was trying to rushed it a little bit, to be honest. That's what happened. So I was like, okay, so you can go higher. So let's keep track of the cost. But I actually have the wrong algorithm here. I assumed that the cost goes up if the current number that you're looking at is greater than the previous number you're looking at, which like index a sub I and a sub I minus 1, essentially. Um, but yeah, and I put in some edge cases. If cost is less than 0, return 0. If yeah, and this is just what I said. If the current or I well current, but current is the last. If the last digit that you passed in is smaller or greater than, then you don't you don't increase the cost. If so, you increase the cost. Uh, but yeah, I was trying to understand, why is this wrong? And I was just looking at my base cases. I was looking at my if statement, and um, so the thing is, at this point, my algorithm is wrong, but I didn't know that. I was I was confident about my algorithm, so I was like, the code is right if my algorithm was right. Well, that's what I was thinking, because I was double checking a lot of the statements, and as a result, I was printing out the things, and now I'm doing print debugging a little bit. yeah, and I'm just putting them out. I was trying, and I also used a case that didn't make sense. So I was like, wait, because I changed the function, but I didn't change my initial kicking off conditions. So I think that's where I was having issues. I was like, okay, um, because my kicking off function is 022. I was like, okay, that means I always start assuming that we already have the number that's highest. So I was like, that didn't really make sense. Not anymore, because before in the decreasing case, you could prove that that was why, but this one. So I'm like looking at the problem again, trying to really understand it. And then I think about now was I was like, oh wait, I misunderstood this, or like I understood this problem initially, but then I misunderstood what I was trying to do, and that would have been it. That change is mostly it in terms of the recursive transitions, but my initial kicking off statements were wrong, I think. Uh, yeah. Basically, you want to take the max of what I call the current and the x, but yeah, and I was like, oh wait, you start at oh, I was like thinking then, I was like, oh, it makes no sense to start at m as your quote unquote your default sentinel value element, uh, and yeah, still a lot playing around. I think this was a little bit trickier because I had to modify, I had to adapt and change my thinking midway. Where if I had actually gotten the right algorithm to think about in the beginning with the cost and everything, this probably would have been done already. Um, and then I was like, okay, one doesn't make sense either because, well, no, I think one is actually the same, but I was still getting wrong answers for this one. For one and zero, it doesn't really matter, I think, because you start at one anyway, and oh no, one it does matter because the cost you increment the cost, and I was like, oh wait, the cost a previous assumption was that I start the cost at k minus one, but now I actually could do this with k, and there you go. I got the right answer and submit. I think I have the other Larry. I think I'm also testing a little bit. Silly understanding of this problem. That's my bad. But that's how I did. Yeah, okay. Just a little bit out of the top 25, maybe. I don't know where I am at. Oh, I guess some of these have penalties, so I don't know exactly. But I should have done that a little bit faster. I just missed parts of that problem. Yeah. Oh. Oh no. Oh well, okay. He wouldn't have. I was gonna say, oh no, ended his winning streak, but oh. Well. But yeah, I mean, okay. So I'm just trying to recollect my dot. That was very stressful, and the problem was that I kind of knew what I misunderstood the problem actually for Q4. So I'll talk about that in a little bit. So it wasn't like I would have gotten it right. Um, it was a fundamental misunderstanding, a little bit of, I mean, not understanding of the problem, just understanding what it would take to solve it clearly. Okay, let's go over the problem real quick. Problems real quick, as much as you like. Um, but yeah, we format the string. Whew, sorry, give me a second. Yeah, we format the strings. So yeah, for this one, I think there are only, well, I was gonna say there are only two cases, but there are only three cases that I list them here. One is length. One is there more alphabet than numbers, then you should put the alphabet first. Second is if there's more numbers than alphabet, then put the numbers first, and then the third, if they're equal, then it doesn't really actually matter. But you have to. But I wrote it a little bit lazily, and how long did I end up taking? I took about 2 minutes 49 seconds because I was trying to be a little bit more careful about this one, and yeah, and that was kind of good. Um, yeah, and I got it right, and and did a little bit, a little bit amusingly. I probably could have. I mean, this. I just wanted to enumerate the cases. I didn't want to take chances on. I knew there were only 3 cases. I didn't want to take a chance on like some weird code optimization for this one that I don't know was prone to getting typo on because you could do like I don't know because this part is the key part where it may be backwards. Um, Display table of food orders in a restaurant. So I took 6 minutes on this one. This is not a 6 minute problem per se. And a lot of people took their time on this one a little bit, or even on the high scoreboards. I suspect this was for the same reason that I did, which is that actually looking back, at least the people who finish off with problems, I actually had a really good time on the Q2, but I actually thought I was a little bit slow on this one, to be honest, because um, because there was just a lot of random edge cases. So I had a couple of edge cases where I was sorting it by the string. You might have seen it, but otherwise it's a straightforward follow the instructions. But yeah, so we sort by string, and I'm actually a little bit thankful about this the test cases because if you sort by string, the first problem, the 10 came before the 3 and the 5 for me because if you sort by string, then 1 becomes the 1 before the 3 and the 5. So there's a lot of edge cases that you have to take care of. But otherwise, yeah, and you have to make sure everything's in string, which was I actually forced myself to kind of copy and paste the answer to another window and then copy check against this because I was returning int, which was not even the right type for both the table and the count, and that would have cost me 5 minutes, and that would have been expensive. I suspect that's where some of the 5 minutes costs came from as well. So yeah. Uh, yeah. Minimum number of frogs quirking. So I actually halfway through. So I end up taking a little bit longer. I think I took like 8 minutes or something like that. Because I thought I was going back and forth between whether we need binary search, and you can actually do this with binary search, and the constraint make it so that it's okay, but you actually don't need to. The idea is that for me is there are 4 possible states, right? Sorry, 5 possible states. 5 possible. I mean, you could have done it a little bit clearer, but I wrote in a weird way now that I look at my code. But basically, you have the states are the the no letters first, and then and then C was the last numbers used, and then and then O is the last letter used, and so forth. So those are all equivalent states, meaning all the frogs that are in those states, they don't they're like you don't have to differentiate, right? So in that sense, that's just a number. And kind of and what I did was I just kind of whenever you get a K, you move the index 1 further along. And as long as it's not and if there's no frog from the previous bucket, then that means that that means we don't have enough frog, or like an R comes before a C or something like that. So like there's no way to complete it, so I return -1. Otherwise, and the only case that I kind of did a little bit weird, and you could have used a variable for this or something like that, but I maybe did a little bit weird, so that I was a little bit not confident about it, so I was testing more cases. But I was using the 0th bucket here in my code to kind of count the number of frogs needed, because the max negative number is going to be the frogs we need. And at the end, when we finish the entire 5-letter word quark, then we we take that frog that we've freed up and then just put it back in the bucket, and that's like how much I'm landing and so forth, and that's how I keep track of the best. And we keep track of every at every instance just to get the maximum frogs that we need. And then at the end, if our frogs didn't come back, we return -1. I also had a silly because I was in confidence, I had to check and test it. One thing that's mad props to the Leetcode contest was that the testing was very fast today. But yeah. So and then because of that, if so, I was putting some stuff, but then I put the print after the if statement. So I was just being silly. But yeah, if you don't get all your frogs back, then you return -1, because at the end that means one of the frogs are between the states, like they're in between a letter. And I could have checked it another way, but this was easier to write because you got to check the sum of the other states. Cool. Build a way where you can find the maximum exactly k comparison. To be honest, I misread this one, or I didn't misread this one, but I misunderstood this one a little bit. In the sense that I thought that a cost would be incurred, and that was my initial algorithm. Well, there are a couple of cases. One was that I looked at this one. So I solved it as a number of possible ways that were decreasing sequence. So if you looked at me as my coding, that's the problem I actually solved, which was wrong, obviously. But yeah, but which was wrong, obviously, because there was a cost. So you even if you watch the video, you'll be like, "Oh, Larry, what the cost? You didn't even use the cost." And then I was like, "Oh, put in the cost." But then because of that, I was a little bit hacky mode, and I was like, "Okay, the cost is just, you get a +1 cost every time a number is smaller than the previous number," which is not true. Or sorry, you get a cost every time your current number is bigger than the previous number. But no, what you want is actually to incur a cost every time you go from your highest number increase. So my recurrence would kind of shift a little bit over time. But basically here, you could even actually replace this variable with max that we've seen so far, something like max seen so far. And that kind of makes it easier to understand properly, where, okay, you have an index, you have a max seen so far or dimension, and then the current cost that you've incurred. So you start with 0, just first index or first item. Max seen so far is 0, so that it's always going to be higher on the first number is a standard value, and k is just the cost that they give you. Not an off by 1 because in the beginning I just assumed that we take the first cost, and that was kind of some of the time. Yeah, and once you change this to max seen so far, this becomes way hopefully clear if you have done dynamic programming in a little bit, which is that and here we can range from O of 1 to m plus 1. And we have to count each one of them individually because, that's how you build a sequence. And yeah, and that's pretty much it. And you can actually simplify this part a little bit by multiplying this because this shows up max seen so 4 times. But that's an optimization that we don't need. And what is the running time? The running time is n times m times k because times m because that's the number of states. The number of states is n times m times k, and each state you do O of m work. So that's n times m squared times k, and k is less than n, so it's n squared times m squared. And it was fast enough for this case. And even though that's technically 25 million, there's actually the math was very hand wavy. It's not hand wavy. It's correct big O, but you notice that max seen so far will not use the entire matrix. So it gets a little bit better after that. And that's the running time, but the space is 100 times less than that. So the space the number of states is okay, and complexity wise is only 25 mil, so that should be okay. Yeah, so that's kind of there's my contest. Let's see where I am now. I guess 21st still. Yeah, it's a pretty good contest, a pretty clean contest. And if you saw me my focus this contest was just not make stupid mistakes. So I do a lot of testing. So I probably, if I was like a little bit YOLO, I would have gotten maybe a minute or 2 minutes faster, and then maybe that would have been better. But I would have also probably gotten a wrong answer along the way. So I don't feel so bad about it. Yeah, I mean, I was way actually looking back, I was very fast on the Q2 compared to other people. But I was really slow on the Q3 compared to a lot of these people. Uh, like I could have probably saved. I think I was just also undecided on that one as well with the binary search, and wasn't sure that that was right because there's a little bit of a mathematical proof that convinced myself, and I took a couple of minutes there as well. So I definitely could have been faster, but in terms of getting it done, but it's okay. Um, and then the last one, I I just I solved. You can almost look at it as I solved three different problems. I solved three different dynamic programming problems, and it only took 10 minutes. So that's not, it is what it is. But that was close. So, but yeah, overall top 25 again. Yeah, gonna be happy about that. Gonna get that T-shirt. And if you like this video, hit the like button, hit the subscribe button, hit everything. Leave a comment. Tell me how you did. Ask questions. Let me know. And I will see you later. Bye bye.